Now that you have worked on identifying like terms, we're going to learn how to add polynomials. The good news is that all you have to do is combine like terms. And again, I've given you a reminder up here. We know that like terms have the same variable and exponent. So what the goal of this is to add apples and apples, oranges and oranges based on variable and exponent. So we're going to take a look at example 1. Here we have 3x cubed minus 3x minus 5x squared plus 2x cubed minus 2x minus 4x squared. You notice here that this addition sign tells us that we are adding the polynomials. Later on, we'll talk about subtracting them, and that sign would be a subtract minus there. So first of all, let's identify our highest degree. It looks like x cubed is our highest degree. I'll put 3 lines underneath it, and I've color-coded to help some of you to identify that this is x to the 3rd power, so there are 3 lines. And I'm going to go through and look at each one of my terms to see if there's another x to the 3rd power. I notice that the first term right here after the parenthesis also has x to the 3rd. So now it's as simple as combining those. We're just going to add our coefficients. So 3x cubed plus 2x cubed, that gives us 5x cubed. Our like term stays the same. The variable and exponent remain x third. We just add the coefficient 3 and 2 and get 5. All right, so let's look at our next highest exponent. I see we have an x squared here. I'm going to use a different color so we can tell the difference between x squared and x cubed. And I'm also going to underline it twice because our exponent is a 2. That'll help us remember that like term. Now I'm looking for something else that has x to the 2nd power. Well, I notice over here, there's an x squared. So now I'm going to combine negative 5x squared and negative 4x squared. That results in a larger negative 9x squared. Again, our variable and exponent stay the same when we are adding. Last but not least, we have negative 3x and negative 2x. Those are both x to the 1st power. The 1 just happens to be invisible. So when I combine negative 3 and negative 2, that gives me a negative 5, and the variable and exponent stay the same. So notice that I put this in standard form, our highest degree to our lowest degree, that invisible 1 on that x. And here is my final answer when I added those 2 polynomials. So let's look at example 2. Here we have example 2. We're going to again add these polynomials. We see that addition sign there that helps us know we're still adding, and I'm looking for my highest degree. Okay, so here my highest degree is 3x cubed. I put 3 lines underneath it to help me remember. And I don't see any other x cubes there, so there's nothing to add to it. If there's nothing to add to it, I'm merely going to bring it down. It's like adding 0 to it because there were no other x cubes, no other like terms to combine with that 3x cubed. All right, so my next highest degree is going to be this next highest exponent is x squared, this negative 4x squared. There are no other x squareds, so I'm merely going to bring it down. Last but not least, I have negative 3x and 2x. Remember, those are x to the 1st. If I combine negative 3 and a positive 2, that's going to result in a negative 1x. Now remember, on a standardized test, you won't see the 1 in front of that negative 1x, so your final answer would look like this. We know that that negative 1 is there in front of x. You just won't be able to see it on a standardized test because they assume that you know that a 1 being multiplied results in the same answer. So adding like terms is as easy as adding polynomials is as easy as combining like terms. So you're looking for your highest degree and making sure you have the same variable and exponent to combine and working from highest degree to your lowest exponent.